Thank you, everyone. Appreciate the showing up to the talk. It's the end of the conference. Everyone's ready to go home, and we're wanting to, get hopefully a little bit of that last of that energy everyone has to maybe have a nice conversation over some interesting information and whatever I have to talk about too. So let's go. Let me start off by just asking you a question. Do you want to change the world? It's really hard to tell what projects are actually going to do that, and some things start off small and then have massive impact. One of those projects I found out recently, I had no idea. There was a podcast platform called Odeo. They had a hackathon, which I know most of you are familiar with. They had a hackathon. They created a small project, and it developed into Twitter. And it was a hackathon output. And that's one of those things I think after you see what comes out of something like that, a hackathon, Elon Musk should increase his budget for hackathons and codathons because he just spent $44 billion for a small side project where people came together just to work on things. So make those some priority. There's a location-based whiskey app. It's called Bourbon. Bourbon wanted to help bourbon lovers and whiskey lovers all over the world come together and share their pictures. People started using their platform not for bourbon sharing, but just normal picture sharing. So they took that project, made it a side project, started developing just picture sharing, and it became Instagram. So these small projects really can grow to something that has global impact. Would you ever think about the small projects that never make it, that could have been there, if they had the right tools, organizational support, they can come together? That is what open source productivity tools platform will hopefully be able to resolve. Give some of those small projects the opportunity to become their potential. Maybe the next Twitter. Well, so who am I? My name is Raul Pineda. I'm the CTO, Leadingbit Solutions. We create, support, manage open source projects for organizations. 25 years in IT field, supporting large enterprise deployments of infrastructure, primarily in the defense contracting sector, but also chemical energy, banking, insurance, and consider myself quite the tech enthusiast, the AI graphics and whatnot, but playing around with those, whatever new tech that comes out. Overall, my entire career, I've spent my time trying to facilitate the projects that people who need to make things happen. They build things, some large groups of engineers from all over this, across the spectrums of all the disciplines. And I've spent the time trying to help enable the people who do things to be able to build all the things. And those small projects and big projects are what we're working towards to try to get there. And the last 2 years I've been working with IEEE SA Open and their community platform. Their community platform is the same as their shared service offering, except for it's the standalone version that any small project should be able to run. We're hoping to be able to deploy, work in, to make their project successful. And we are hoping to give that opportunity to those small projects to be able to function just like they're using Google Workspaces or Office 365, but to be able to do it on their terms and hopefully smaller budget. So the benefit for changing to an open source platform, I'm sure most of you in here, being this is the open source conference, have got a lot of the basics out of the way, but going to go over some of those and we can talk about some of the high points of the benefits of trying to use an open source tools compared to their proprietary equivalency. So cost effectiveness. Open source software is usually free, as they say, free to use, but usually that means free to not be licensed. The use case definitely still costs money. You're having to spend for support, you have to spend on maintenance. If you want to maintain it so your users have it available when they need it, again, to prevent that system failure. But that same cost is still going to be needed for proprietary software. We're trying to say that you get this low cost of entry, but with the right tools and configuration, we should be able to move forward and to hopefully decrease that cost of operations because it's open source. Open source has enhanced security compared to proprietary software, which usually has more of a security through obscurity, which really isn't a benefit. You know, vulnerabilities are often identified just when once someone figures out how things work. Way back, you're going to talk about like just early in my career when I really didn't know a lot about getting around on a computer. I was doing computer repair in college, while working through college, and someone came in and brought their PC in, and they had trouble getting it logged in because their password was not working. So they asked if I could look at it, and I was like, okay, how do I do this? I have no idea. I don't know much. Started just going, well, let's see. If I create a user, what files change? Okay, now let's look at those files. What's in there? Oh, there's data. If I create another user, how's that different? Oh, then I looked at the differences in those file creations, and I was able to reverse engineer their entire encryption algorithm for an actually popular calendar software that had been out for years. If it was an open source project, one, I could have had somewhere to really report this issue. It's not like I was some massive hacker trying to break down this security of the software. It doesn't take much, but with open source software, you can see how the code's set up. You can have an avenue to report your issues. And through that, enhanced security through transparency, you get review from the community, you get faster vulnerability identification, and resolution for security issues. So it's highly customizable. Open source software allows you to change things as you want. You have the code. Proprietary software, if you want to make any changes in the proprietary software, you can make a suggestion. They'll ignore you. And or if they do implement it, it's usually never on the time frame you want it. With open source software, you can make these changes, and then if it's good enough, return it back to the project and share with all the users. And so you actually impact and better the lives for everyone else who uses it to get the functionality you were looking for. Interoperability, it's easy to say that linking to other software, it should be easy. If a proprietary software doesn't want you to be able to share your data with some other application, you're pretty much out of luck. They might give you APIs, but that'll be limited. You can work with the project on an open source project to get the functionality you want out of it and integrate to other open source projects or proprietary ones because you have that access to make the changes. Those changes spur innovation. Faster innovation development gives you more features, technology. But here's the biggest thing I feel open source software provides: a community. The people like at this conference, they work together to try to make things better, even if it's a competitor, because a lot of people in the community really want things to work better for everyone. And some proprietary software are nice, but in the long of it, they're going to be looking out for their profits more. That if what you want doesn't coincide, again, you can look to Twitter. They're now closing their third-party APIs. So what you thought you could rely on to be accessible proprietary software could just easily be taken away. So control of data, especially with the standalone installations of open source software, you know where it is, be it allocated in your own server, be it allocated in cloud storage. You have an idea of where it's located. If you work in a proprietary software SaaS service or hosted by someone you're not sure, you don't even know where the data might be. And if your software provider is putting data in unexpected locations, even though you might be in one spot, they're doing a copy somewhere else, you might have unknowingly violated data export controls for whatever you're trying to do. It's the way you can control your data locally with your ownership. You can make sure it's how it's accessed, how it's stored, and how it's encrypted. You don't always get that options for every layer in proprietary because you don't get to see it. So compliance. In working in the DoD sector, finance, banking, insurance, for some reason they're real particular about their data, which I get that. Spent the last 2 years working for a defense contractor, almost entirely focused on trying to get our compliance reviews done, writing hacks around gathering data to meet this need to be done, code red, compliance software requirements, or we can no longer provide services. With a proprietary vendor, if their needs don't meet your compliance requirements, you're not going to be able to keep working in the sector that you're in. It looked like GDPR, and another one of those things, looking into GDPR, I learned about how many people are who might be like under GDPR or citizens of the EU, but they don't actually have to, they're still, it's extended to them all over the world, no matter actually where they reside. So, like there's a German data protection regulators, and they spent the last 2 years looking into the privacy concerns of Office 365, and they've cranked up pressure that you need to make sure you can meet how the data is stored for when you're collecting people's information. So with open source software, you know where the data is stored. You can figure that out. You can gather your responses to your compliance inquiries easier. Be able to meet GDPR, HIPAA, SOC 2, DFARS. But going on to IEEE SA Open's community platform, we worked with their advisor groups to try to figure out what tools and abilities do people need when they try to make a project work to be successful. What's a 100% requirement? What's just a nicety? What's optional? Define functionality. We created, working with the community, a definition of what is not just to be how to create code, but how to have a successful project. The communication, tracking of tasks, as well as how to do logging. It was like, what are the requirements? So we worked with the advisor group to come up with that. The technical advisory group, put together a way to have a workflow to define if you have a suggested tool, does it meet the right tool requirement? That workflow was set up, and we were able to create POCs based off of their tools. The users got to use and give their feedback to us. We see how it integrates with the other applications that were created on the platform, and until we can say, okay, this functionality is available for everyone. Can this work? Now, how do we get it to deploy? How do we make this easier for if you're not just if you're a developer, but you're also just a team member. You don't have to be this DevOps genius to get these things working. The tools we're talking to discuss will be the main ones for the platform: Mattermost, GitLab, Nextcloud, Big Blue Button, and Open Project. They're the equivalents to like GitHub with GitLab with GitHub. Mattermost is the open source equivalent of Slack, which is very useful. the big blue button using to replace like a Zoom function, and Nextcloud to replace your Office 365 document creation and curation and tracking. So yeah, the GitLab functionalities are definitely beneficial for creating code, and CI/CD, version control, the wiki, get the team members interacting on that, but that linking into the other applications like open projects, so create tasks based off of issues that are driven up. Nextcloud, you can get into your calendar in there, access, create documents that go along to the projects, and it actually ties it all together really well. We can see alerts when things are going through your pipeline, or you have an issue track that you need to address. You get an alert. Mattermost, it's been fantastic for that chat communication. We found that a lot of the teams really get productivity more than email, more than even interacting in GitHub or GitLab, is the ability just to chat back and forth quickly and get some real-time responses. And then there's Big Blue Button, which is like the Zoom equivalent. The functionality we get out of Big Blue Button has been really nice. It really brings people all over the world without much latency. Works in a browser with the functionalities that were the same or better than we were getting out of Zoom. And then again, you control where your recordings are stored and how they're accessed. So, how did we start this? Well, it's a long road, and first we had to look at this as our primary objective was to find a way to give project groups of all size and abilities the way to access these open source productivity tools on their own hosted services that would make them functional, but in a way that they could deploy it without, again, having the expertise, not having to ensure that it's secure. We work as the community to figure out, like, what are the best ideas on how to meet the security demands? How do we create the audit logs or the processes to audit it correctly to validate the security? How do we move forward in deploying it safely and resiliently? We chose to set it so we can automate our processes in AWS. That was one of those initial starts. We want to be able to have it be able to deploy in Azure and GCP, but we picked AWS because of the highest access across the globally. We set up the proof of concept environments, and then we had to learn how each application worked. How did they break down? How does it scale properly? How is the best way to back it up? What's the best way to test it? QA testing, how does the update process work for their applications? How often is that? Is it on a larger schedule to be able to, you can rely on to be updated? Or some of the smaller projects we reviewed, their updates didn't meet a lot of the security issues that came out, so you had to find which were production readiness, which applications were the best to go with. So we got all these things, set up the proof of concept. We have users constantly using it so we can knock out the bugs, realize what does work or doesn't work. Because there's so much more to get them integrated together than it is to just set up a standalone instance and just have a couple of people just try to log in and say, oh, it works. We took all the information of what we learned from the individual POCs, and then we designed a highly available, scalable, resilient solution that hopefully they could recover from system failures. And for some of these applications and their deployments, they weren't as, for the community edition, they weren't really set with the functionality to be resilient. So we had to find ways to work around that. It brought up some challenges, and these challenges, we want to go over what we faced when we tried to set up, or some of the same challenges you're going to face when you try to just propose open source software to be used in an environment. We had some difficulty finding skilled personnel to maintain the software that are specific to the application, because the user base for their projects were smaller. The way we handled some of that was with we had to allocate more time to learn those aspects of the application, and how do you solve it, how do you troubleshoot it, and then document everything that we've discovered, share it with anyone else who's using the same tools, and then make sure we had them backed up. We had great points to restore to if a patch or update would make something in our configuration fail, even though it may work fine in a standalone, it would not work in our implementation. We have had some limited documentation issues. Try to figure out when there's a new function, when someone adds something that is not always on how to implement it or how to use it, is fully fleshed out. We try to put it in place. Again, those POCs really help test those things before you put it into production, and you have a point to roll back to if it just doesn't work for those scenarios. But it really emphasized the need for a higher level of QA, and the QA was going to be basically the deployment base, treating it like it's a full code deployment instead of an application patching. We had to validate all the different aspects of it and have that checklist. So we help create those checklists of what anyone who wants to use this platform on these applications and configurations, how do you validate before you put it into place to fool your users that it's going to continue to work. It's not just, it's up. Just because the process is running doesn't mean the application is available. So we took the time to address these challenges, and we're working towards different ways to extrapolate the data out of the base application deployment, so we can change out that instance if it's failed and not lose or impact any changed data. It's at times if an update would fail standalone, but if we install the whole thing with the new patches or changes, that would work. So then we just migrate in, but we also had to have that process documented properly to be able to move on to make us more reactive. So we were keying in on being resilient and highly available. Using cloud infrastructure is definitely have a lot of options. You want real-time access in multiple availability zones. You want to make sure your traffic isn't lost. Your data, what's the return time to access your data if there's a failure. But they added a lot of complexity, as well as a lot of, going back to that cost opportunity, the cost variable, it's a lot of resources to continue that resilience. So we talked to some of those that they wanted smaller, but we still wanted to make sure that you could rely on it to be available, that it would restore itself if there was a failure. So we changed from this to take implementations that were for each application in the thousands of dollars a month to something much simpler that we could say deploy and be at $100 a month per instance that's there, easier to manage, but still if a system fails, it'll auto recover, come back. And we were trying to develop the infrastructure as code, so the end user, again, could be anyone. It doesn't need just to be the technical developers or operations people to set this up. You can roll this out, and use the same architectural structure for each application. That's what we're shooting for. We don't have I would say we have all the answers on how the best way to do it, but we're hoping to work with the community. If anyone else who wants to do this, we're open sourcing the entire effort. And we're trying to, with that process, optimize the maintenance costs. The effort shouldn't be something we all have to repeat to learn when something breaks. If we have a community that can support this environment, then that's one of those costs. How do you make sure it's patched? Some of the things that keep them from getting there is a lot of people don't even know if the technical details to set it up. So we're trying to take that off the table, give you documentation on how to maintain it. And what we're trying to, in the current iteration, it's like a single instance, the EBS volume that can share between the auto-scaling group as it changes and a new one is replaced, so we keep that data separated from the application and getting everything set up through code. But we would like to move forward to a containerization of the applications and to Kubernetes and whatnot, and that's where we would try to work towards. So a recap, let's say the open source software productivity tools are hopefully a benefit to anyone who wants to get their projects to work. If you have a team of students, a bunch of friends that want to make an app, hackathon or a codathon, that project, you shouldn't have to spin up or set up a large implementation, and it should be easy. And we're hoping to be able to get those readily available to make it so the diversity of roles is empowered to also participate in projects without having to wait for those technical resources to deploy things. Because in larger organizations, that's some of the bottlenecks for asking for a system to be implemented. You could be, in large organizations I've worked in, it could possibly be months. And for open source communities, that's definitely not going to work. Definitely would want to say if you want to reach out and have any questions about what we're trying to do, actually let me go back to the link. I didn't move it on there for the project itself. It's at the bottom. We're trying to have our GitLab project based out to get more engagement. I'll be sharing that out with the slides when get a chance on the setup of communication back to anyone who's interested. So thanks everyone for coming to my talk. If you have any questions, like I said, please reach out, and we'll try to make this deployable platform of open source productivity tools something available for everyone. So, thank you.
Let's give Raul a big hand. I'm not sure I'm on. Okay, do we have some questions from the audience? Yes, hand straight up. Yes.
You might have answered this already, but you mentioned, so you went with Mattermost for messaging, and I just wondered, were other options evaluated, such as Matrix, and what were the factors that led to the choice of Mattermost?
So, and it's one of the things, the community came and looked at a lot of those different aspects of the UI, the ease of use and familiarity of and there were like Matrix and Rocket Chat were definitely ones that were considered, but they felt at the end that Mattermost met their needs moving forward from the community version to get the functionality.
Sorry, it's all actually up and open on the platform for IEEE SA Open. If you go to opensource.ieee.org and look at the technical advisory group, they have the process written out there for submitting tools. They have the discussions in regards to it, the same thing for features, and also the other different stuff. Sorry, I run that part of the community. So yeah, it's all there. The Leadingbit is separate, but we support it. So when we can. Mm-hmm.
And the platform itself is one of those things, it's going to be dynamic. If something could potentially feels as a need, the idea is like you're not locked in. It could be changed out. As far as the community platform is concerned, not the shared IEEE one.
So great talk. Really, really enjoy this subject, as I'm sure you know. But I'm curious if, I know this is fairly early for a project, but the addition of new tools as you get more people involved, could you speak a little bit about, like, let's say I wanted a tool like PenPot because my organization does lots of design, but maybe that's not needed, it's not a core thing. Do you have any ideas around like core supported tooling within this, within SAOpen, and maybe like ones that are supported by outside communities?
So it definitely, I feel the community is going to be, have to decide if that's the way that they want to use it. You can hopefully be able to roll out this, and you can use the same structure and code and change out the application and say, for your instance, it's like that. And then add two into the project as a without the consensus of the entire group, but it's available to integrate in. And some of those, it's the deployment plus those integrations that really make the difference in saying this is a platform, because anyone can just spin up these different applications, but without the functionality and data going between them, it doesn't get the cohesiveness that really helps make it an engaging tool to be productive.
I don't have a question. I just had a comment as an IEEE SAOpen volunteer on Mattermost and on Nextcloud and on the other items that is being used on the platform. And also I come from an open source intelligence background where I enjoy looking at the vulnerability of things, and I like to break things. So the first thing is on Mattermost. I got a full review today on Matrix, and I'm very excited to play with Matrix. But the Mattermost is very nice for this kind of community-driven thing, and it's set up in such an easy way that somebody who's very low-tech to high-tech can employ it. And so I really appreciate it. And then the other thing I really like about Mattermost is that it has a lot more privacy to it than I would get from some of those big tech options. Then on Nextcloud, the thing I like about Nextcloud is it has a lot more respect for my private data than like Google Cloud would have. So that's another thing that I appreciate. And then with the Big Blue Button, which I absolutely adore, as somebody who occasionally volunteers to teach youth about digital responsibility, is that Big Blue Button also respects your privacy. They're not keeping your recording, and it's open source, and you can actually see the code of it, and I just feel safer using it. So that's all.
All right, wonderful. So thank you so much to Raul. Let's give Raul a big round of applause. Thank you. Thank you also, audience, for your questions and comments.